चलिए, so today I'm going to discuss with you question 46 onward. The first question is question 46 of miscellaneous exercise of definite integral of integral. So this is 0 to power 2 sin x cos x upon cos 4x sin 4x is to dx. अभी देखिए, when we will solve this question, okay, in this question, divide numerator and denominator by cos 4x to convert it into 10, 0 to pi by 4 sin x cos x upon cos 4x over cos 4x plus sin 4x divided by cos 4x is to. So I did the division of with cos 4x. This is equal to 0 to pi by 4. Now, one cos goes with this, so I can write sin x upon cos x 1 upon cos square x dx upon 1 plus tan 4x, which is 0 to pi by 4. Tan x is to secant square x dx upon 1 plus tan 4x, which can be written as 0 to pi by 4. Tan x is to secant square x dx upon 1 plus tan square x whole square. I hope Jab and Kiran are getting.
Yes, sir.
Now, if I will substitute tan square x as a p, so derivative of this is 2 tan x is 2. Derivative of tan x, this is secant square x dx, this is equal to t. So you can write tan x is to secant square x dx, this is dt upon 2. So my question becomes dt upon 2 is to 1 plus t square. Now we will change the limits. When tan 0, t is equal to 0. When tan pi by 4, tan pi by 4 is 1, 1 square is 1, so this is 0 to 1. So limits will also change accordingly. So which is equal to half is outside, 0 to 1, dt upon 1 plus t square, which is equal to 1 by 2 is to 1 by a is to tan inverse x by a plus c, which is 1 by 2. Tan inverse, the value of this is t upon 1. C will not come because it's a definite integral. So this is 1 by 2. Tan inverse 1 minus tan inverse 0. So this is 1 by 2. Tan inverse, this is pi by 4 minus 0. So pi by 8 is the minus. Any doubt you can student was this was a simple question. It was expression in this question. Next question is I'm leaving question 27 for you. Going to question 20. So, important question, question 28. Miscellaneous. This is pi by 6 to pi by 2 sin x plus cos x upon sin 2x under root is to dx. Online students, when you will note it down, please let me know. Then I will start with the next question after rubbing it. Herman, हो गया बेटा? ये तो simple था. There was nothing complex in this question, but this question here you have to see how to proceed because there are few questions which can be solved with the set method only. अब जरा इसमें ध्यान देना. Sin 2x in the denominator, sin x plus cos x in the numerator. If I will suppose sin x minus cos x as a t, so derivative of sin x is cos x. Derivative of cos x is sin x is to dx is equal to dt. My derivative is in the numerator. If आप बोलोगे ये कहाँ से आया? This I have to take from. I have taken it from my side. If I will suppose it as a t, the derivative of this is in the numerator. But I have to convert sin 2x into this form. How I will convert इसको देखो. If sin x plus cos x, ये देखो. Sin x minus cos x if it is t, squaring both sides. Sin square x plus cos square x minus 2 sin x cos x. This is equal to t square. This is 1 minus sin 2x cos 2x क्या बन गया? Sin 2x. This is t square. So from here minus sin 2x. This is t square minus 1. So what is the value of sin 2x? This is 1 minus t square. So if I will suppose sin 2x as a 1 minus t square, this will become my t. So which implies my question becomes, ध्यान देना, ये मेरा क्या बन गया dt. What is the value of sin 2x? This is 1 minus t square under root. Now I have to change the limit with my substitution. That means when x is equal to pi by 6, sin pi by 6 minus cos pi by 6 is equal to t. So sin pi by 6, this is 1 by 2. Cos pi by 6 under root 3 by 2. This is 1 minus under root 3 over 2. So 1 minus under root 3 over 2. This is my lower limit. So when x is equal to pi by 3, sin pi by 3 minus cos pi by 3. This is under root 3 by 2 minus 1 by 2. So upper limit is under root 3 minus 1 upon 2. So here, how to substitute the thing, that is very important. I have substituted sin x minus cos x as a t by, because the derivative of this is in the numerator. Now, a square minus x square under root, the value is in the term of sine. So sine inverse. So this is sine inverse t upon this is to 1 minus under root 3 by 2 under root 3 by 2 minus 1. So which is equal to sine inverse minus. This is the answer. You can solve it further by taking negative outside. Sine inverse under root 3 minus 1 over 2 minus sine inverse. Take negative outside and make it like this. Sine inverse minus theta is equal to minus sine inverse theta. So this is equal to minus minus plus, which is equal to 2 sine inverse. This is the answer. I hope this is clear for online students. Now, for all the students, I'm just discussing with you. The first thing is September 3 is the last day to cover, is last day to finish term 2 syllabus. Your revision will start from September 4 onwards with mock test and assignments. September 4 onwards revision for entire syllabus with mock test plus assignment. The weightage of those mock tests will be counted. Clear? September 4. The entire September will be for revision. In October, you have your 2 pre-boards. This will be the course of action. Jab, is it fine?
Yes, sir.
Kiran?
Yes, sir.
Kiran?
Yes, sir.
Kiran?
Yes, sir.
Abhishek Saini?
Yes, sir.
Abhishek Saini?
Yes, sir.
Great. So for the entire September, there will be a mock test, and preferably the mock test will be offline in the class. Fine. So rest, revision and assignments, it is up to your choice. But I want that mock test should be in the class and the weightage should be marked for that. Fine. Thank you. Come to the next question. So within a day or two, I will share the syllabus. So I will share the schedule of the entire September with you people. पूरे सितंबर का कि किस दिन कौन से चैप्टर की रिवीजन है, कौन से चैप्टर का टेस्ट है, वो सारे का सारा that I will share on the portal as well as. Come to the next question. 29 have been come to question number 30. Again, why I'm going to discuss with you the question 30th, because question 30th is of the same type as we did question 28. And all these questions are very important. Results of these questions are very important. These questions are theorems in itself. Question 30. This is 0 to pi by 4 sin x plus cos x upon 9 plus 16 sin 2x is to dx. We will go to the same method as we did for question 20. See, sin x plus cos x is with me. So I will try to suppose sin x minus cos x is equal to t. When I will take the derivative of sin x, it is cos x. Derivative of cos x, it is minus sin x. So plus, this is dt. So this is my dt. And this is my dt. Now, from this t, I want to go to sin 2x. So squaring both sides. Sin square x plus cos square x plus 2 sin x cos x is equal to t square. 1 plus sin 2x is equal to t square Sine 2x is equal to t square minus 1. So this is the value of sine 2x. So अभी जरा देखिए integral of this is dt upon 9 plus 16 t square minus 1. When e is equal to 0, when x is equal to 0, this is sine 0 minus cos 0 is equal to t sine 0 0 cos 0 1. So this is minus 1. When x is equal to pi by 4, so sine pi by 4 1 by under root 2, cos pi by 4 1 by under root 2, so it is 0. So which is equal to minus 1 to 0 dt upon 9 plus 16 t square minus 16 minus 1 to 0 dt upon 16 minus 9 7. So 16 t square minus 7. Sorry, I have done something wrong in calculation. When I did squaring on both sides of equation for 1, there is a sign of negative. So this is minus. So this is t square minus 1 minus sine 2x, which implies sine 2x is equal to 1 minus t square. So the value of sine 2x is 1 minus t square. So please read the calculation. 1 minus t square. So this is 9 plus 16 minus 16 t square. So this is 25 minus 16 t square. So which is equal to, take 1 over 16 outside, minus 1 to 0 dt upon 25 over 16 minus t square. So which is 1 over 16 minus 1 to 0 dt upon 5 over 4 whole square minus t square. So this is dt upon a square minus x square. So this is equal to 1 by 16, 1 by 2a log a plus x upon a minus x minus 1 to 0. This is 1 by 16, it goes to 2 by 5 log, this is 5 plus 4t upon 5 minus 4t minus 1 to 0. So this is 1 by 40 log, it is 5 plus 0 upon 5 minus 0 minus log 5 minus 4 upon 5 plus 4. 1 by 40. This is log 1 minus log 1 upon 9. Log 1 is 0, so 1 by 40 minus is 2 log 1 upon 9, which can be solved further. This is 1 by 40 negative. This is log 3 raised to power minus 2, which implies minus 1 by 40, minus 2 comes at front, log 3, minus minus plus 2 by 40 log 3. So this is 1 by 20 log 3 is the final. So again, the question goes in the same way as we did question 28, but at the last only the formula difference is there. So you have to remember those 6 results, because those 6 results will be used again and again in application of integrals, in differential equations. वो सब में आपका यूज होगा, बार यूज होगा. Yeah, but rest of the things just repeat, they repeat itself. वो बहुत ज़्यादा मुश्किल नहीं है, as we will see. The same replication goes as that of question 20. But this is again very important. That question was very important because they are the part of the paper for 3, 4, 5 times. So these are very important. Note कर लीजिए. I'm giving you 2 minutes. Online students, please contact me. Then we'll move to the next question. Now, come to question number 30 after this. Today I will finish it, and from tomorrow I'm going to start with the application of integrals. Because we have 2 periods today. So I'm trying to do each and every question in a class. And after telling you repeatedly to discuss your problems with me, and this is on record. But still, if you are not discussing, then this is your fault, beta. Jab, I hope your activity notebooks are ready.
Yes, sir. There are only six activities.
Yes, 6 activities are there, and those who are online, please complete your activity notebooks and bring it to schools when you will come, because I have to check and I have to retain it with me. In the second term, I will return it to you, because those activity notebooks can be checked by the board representative when your exams will start. Fine. So that is the result.
Okay, sir.
Okay, sir.
Chलिए, come to the next question. The question is 0 to 5 x 10x, question 32. Upon secant x plus 10x. Okay. This type of example we have discussed also, where one variable and one trigonometric function is involved. So I told you at that time also that we have to use the property to separate the people. So manage solution में let I is equal to 0 to 5 x 10x upon secant x plus 10x is to dx. I is equal to 0 to 5. This is 5 minus x. 10 5 minus x upon secant 5 minus x plus 10 5 minus x dx. I 0 to 5. This is 5 minus x. 10 5 minus x. This is in the second quadrant. So this is minus 10x upon secant 5 minus x in the second quadrant minus secant x, and then minus 10x is 2t. So minus I am going to take it common. So it will cancel in the numerator and denominator. So this is 5 minus x is to 10x upon secant x plus 10x is to dx. Now I can write it into two terms. I is equal to 0 to 5 10x upon secant x plus 10x dx minus 0 to 5 10x upon sorry x 10x upon secant x plus 10x is to dx, which is the same as that of my initial thing, which is I. So I'm going to suppose that I is equal to 0 to 5 10x upon secant x plus 10x minus. This I goes to the side. It will be 2y 0 to 5 10x upon secant x plus 10x is to dx. So because phi is a constant, I'm going to take it out. So this is I is equal to 5 by 2 0 to 5 10x upon secant x plus 10x. Now what are the good? My question is free from variable. There is no variable in multiplication. So what I will do, I will try to make it simpler. I is equal to 5 by 2 0 to 5. I can write it as sin x upon cos x. 1 upon cos x. Sin x upon cos x is to be. I is equal to 5 by 2 0 to 5. So this is if I will take cos x as LCM, it will be sin x 1 plus sin x is to be. So we can make it a simple by adding 1 and subtracting 1. Like 0 to 5, 1 plus sin x upon 1 plus sin x minus 1 is to be. So which is 5 by 2. 0 to 5. I can write it as a 1 plus sin x, 1 plus sin x. Minus 0 to 5, 1 upon 1 plus sin x is to be. Which is equal to 5 by 2. This cancel. So this to dx. This is integral of 0 to 5 dx minus. I can rationalize it. This is 0 to 5 1 minus sin x upon 1 minus sin square x is to dx. By multiplying numerator and denominator by 1 minus sin x. So which is 5 by 2. Integral of this is x 0 to 5 minus. So this is 0 to 5 1 minus sin x upon cos square x, which is 5 by 2 5 minus 0 minus 0 to 5 1 over cos square x secant square x dx minus minus plus 0 to 5 sin over cos, this is 10x 1 over cos, this is secant x dx. I have made the simplification here 1 over cos square x, this is secant square x. Sin x over cos square x means sin x over cos x 10x 1 over cos x secant x. So this is 10x. So which is 5 by 2. This 5 minus secant square x 10x. This is 0 to 5 plus 10x secant x. This is secant x. 0 to 5. So this is 5 by 2, 5 minus 10 5 minus 10 0 plus secant 5 minus secant 5 by 2, 5 minus. What is the value of 10 by? It is 0 plus the value of secant 5 minus 1, secant 0 1. So which is 5 by 2, this is 5 minus 2. So this is the answer. 5 square upon 2 minus 1. Or you can write. Any doubt or any problem to any of this? Those who are watching online, beta, इसको आराम से नोट करना, कोई difficulty, doubt, you are free to discuss. अरुण आप एक बार अच्छी तरह बता दीजिए. कोई doubt, difficulty? Yes, online students, any doubt in any of the steps?
No, sir.
Okay, come to the next.
No, sir.
Question 4. We have 3 minutes with us. Quickly, just I'll give you the hint how to solve the question. This is not a tough question. Question 34 is an easy question. You have to apply the concept of partial fraction. The question is, this is I think it's 1 to 3 dx upon x square x plus 1. So, first we will solve the things which are in the integral. This is a upon x plus b upon x square plus c upon x plus 1. We did the concept of partial fractions. So this is a is to x is to x plus 1 plus b is to x plus 1 plus c is x square. So which is a x square plus ax plus bx plus b plus c x square. So this is a plus c x square. A plus b is to x plus b whole. So when I will compare both the sides, constant b is equal to 1, a plus c is equal to 0, a plus b is equal to 0, so a is equal to minus 1 and c is equal to 1. Put the value of a, b and c in number 1 and integrate under the limit 1 to 3. Put the values in number 1 and integrate under the limit 1 to 3. 1 to 3. So this will become 1 to 3. A is minus 1 by x dx plus 1 to 3. 1 upon x square plus 1 to 3. 1 upon x plus 1 is 2 dx. This is the answer. So that's all for today. So try to complete it. So final difficulties that you will have, I will discuss it tomorrow. Then we'll start with the next chapter tomorrow. Thank you.